Today we are going to discuss what we call conic sections. And these conic sections, I'm going to show you some of the relevances of some of these areas, conic sections. We began with a circle. Of course, a circle is also a conic section. But there are these special cases that come in when we have items like parabole, hyperbole, and rectangular hyperbole. Now, when you look at our bridges, for example, those bridges, when you see them and the flyovers, they have a curve in nature. They are designed with the curves. One, there can be a curve on the bend as the cars are moving. Then there can be a curve due to the poles, the way they have designed the poles to hold the bridge. So those aspects they use, or the concept they use in mathematics, comes from these areas of conic sections. Like you can see this bridge. If you look at it carefully, you see it has such a curve, something like this. Then it is going to go on and reduce and go down. Then this way it's going down as well. The same applies here. It ascends, then it goes down. The concepts which are here are parabole and rectangular hyperbole, as we shall see. So I wanted to show you where these relevances are. Some people always ask, but teacher, where are they applied? You see this bend is trying to ascend up, but in actual sense, when it ascends back down, it forms a shape of a what? Of a rectangular hyperbola, or it can form a shape of a. Of course, bridges can't be at a sharp angle like the parabola, so they can use rectangular hyperbole and hyperbole. Then also you've seen these circular measures on roundabouts. If you've taken a look at your roundabouts, wherever you are, there's a roundabout here on Kampala Express Highway, which I want to show you. See that roundabout? It is a circular measure coming from a conic section of circles. Yeah. So vehicles can negotiate around this bend of that circle, depending on where they are going, and then they can climb to whatever lane they want to climb. Yeah. But still, where the flyover is, there is a curved or there is a bend. So if you go using that road of Entebbe Express, for example, for we who are in Uganda, that is a very good image to investigate and check out. These are other countries, I guess, which are not Uganda. So basically, that's one of their relevancies. So those of you who may ask and be like, but where do we apply such knowledge, such concepts in real life? Those of us who want to become engineers, those of us who have visited those serious countries with very beautiful roads. You see how they construct them? They are ascending down, but they have a pivotal axis, which we are going to see in these definitions we are going to discuss of these areas. That pivotal axis will always have what we call the focus. So always every bridge which is curved has a focus, meaning if someone wants to destroy it, we'll just have to look for that focus. And if you destroy the focus, it can easily bring down the bridge. So I think that's what I can stop at today for those illustrations. Further illustrations, you'll see them as you pass by the roads. On those roads, if you visit those roads around Entebbe, now they're constructing the Ginger Highway. There's the Kampala flyover at the Queen Towers, which is also being constructed. All that math comes from this area. Okay, so with that, let us straight away identify them. They include the following. 1, a circle, that one we have seen. 2, a parabola. 3, they include what we call an ellipse. And 4, they include what we call a rectangular hyperbola. I briefly talked about it when I was curve sketching, but if God allows time, I don't know, we are supposed to end the lessons next week. So I don't know whether you can arrange some extra time. We as people who are going for candidate classes, we might have some free lessons along the way. So when we have some of those lessons, you can borrow more time and you go and you've concluded all these areas. So we are starting with the parabola. So a conic, by definition, if I can start the parabola, I can say a conic is a locus of points. Locus of a point which moves so that its distance from a fixed point, bears a constant ratio to its distance from a fixed line, to its distance from a fixed line. Someone is in the chat. So what if we use night of this week? You agree and get back to me. But it's always better for nights from Wednesday and beyond. So in this case, we can have an illustration to describe this. And in these illustrations, we can have the following. We can have a perpendicular distance from the line. And then we have a fixed point, whereby if this is the line, then the perpendicular distance from this line at point M to a point P, this P moves in a way that the ratio of the distance from a fixed line to a variable point S, which S is what we shall be calling the focus. This point S is fixed and the P moves. So P, the distance of P from a fixed point to a given line, which is also fixed somewhere away. This is a fixed line, which line we normally call the directrix. Okay, so we are saying point P moves so that the distance from a fixed point bears a constant ratio to its distance from a fixed line. So with that note, the distance, for example, SP, its ratio to MP is supposed to be equal to E, and this E is what we shall be calling the eccentricity of the parabola. So if that ratio is a constant, then it is describing a conic. Now, to note more on this, we can say the fixed point is called the focus. The fixed point is called the focus. And the fixed line is called the directrix. Okay. The constant ratio is called the eccentricity. The constant ratio is called the eccentricity. It's called the eccentricity, E. P is a point on the locus. P is a point on that locus. And M is the perpendicular distance. M is the perpendicular from P. Sorry, M is the foot, not the perpendicular. M is the foot. Is the foot of the perpendicular from P to the directrix. To the directrix. So the perpendicular from P, if M is the perpendicular from P, which meets the directrix, remember this is the directrix, then that is what we are calling our M. So, and therefore, the eccentricity, if it is equal to 1, then the conic is a parabola. Then 2, if the eccentricity is less than 1, then the conic is what? Is an ellipse. So next week, I'll introduce ellipse on Monday. Then 3, if the eccentricity is greater than 1, but for the ellipse, I need a lot of trig. Even the hyperbola, we need trig, rectangular hyperbola. So your trig should be sharpened. So we shall have the conic is a hyperbola. So those are the basic introductory parts we can have. So can we officially go to our parabola? So main heading now, parabola.
Excuse me, teacher.
Yes, please.
Now let's go back. I just want to take a screenshot, please.
Okay. There you go.
Thank you.
You're welcome. So by definition, we can say a parabola is a set of points in a plane that are equidistant, from a fixed point. Remember, the fixed point is what we call the what? The focus, and a fixed line. A fixed line, which we call the what? The directrix in the plane. I.e., if you recall, we have said, i.e., for a parabola, it has what eccentricity? Habiba. Habiba, what is the eccentricity of a parabola? Is Habiba there?
Teacher, it is equal to 1.
It is equal to 1. Thank you so much. Now, remember, because we had seen this illustration before, and we had said that conics move in a way that there is a distance, there is always a ratio of the distance from a fixed point PS to the distance from the foot of a perpendicular to the directrix to the variable point PM. And we said if the eccentricity is equal to 1, then it is a conic, which is describing a parabola. So for a parabola, we are saying it is a locus of points which moves, or a set of points which moves in a way that the distance from a fixed point is equal to the distance to the directrix. But what does that mean? It means the SP you had before over PM you had as well, that distance is supposed to be equal to the eccentricity of the parabola. But in this case, SP out of PM, because the eccentricity of the parabola is 1, then the distance of the fixed point, which is the focus, is always equidistant to the distance of the directrix to the variable point P. That is why they become equal. So this is the most important definition that brings about a parabola. So with that, we can introduce the equation of a parabola. Equation of a parabola. Whoever will not have enjoyed these definitions, when we derive the equation, we can start from there and be in position to go ahead and see whatever we want. So let us first have the illustration. We can have an illustration of our parabola in this form. One, I can draw this as my perpendicular. Then this can be my y-axis. Then this can be my x-axis. So with that sense, I can have this located very well as this is x is equal to 0, which is our y-axis. Then this is the axis, which is y is equal to 0, which is our x-axis. Now on the x-axis, we have there a focus, S. This focus has a constant A, 0. Now, if this is the parabola, let me sketch it for you. That is how our parabola looks like. Then our variable point on the parabola P, which describes the parabola P, is here xy. Then the distance from P to the focus S, that distance should be the same distance from there to what? To the directrix. So if the distance is the same as that of the directrix, then I'm assuming this is where my M is. This is the perpendicular of the foot from the directrix. And the directrix, I'm assuming, is at a point, say, where x is equal to negative a. So this point M will be negative a y, because this is a horizontal line. Now, remember, we are assuming this distance is the same as this distance for a parabola, okay? If that is the case, then this is the origin 0, 0 of the axis. So with that note, if I can proceed, check out this here. You will see that if you look at the distance from here up to here, and then the distance from there, you have a distance from there up to here. All those distances are along the horizontal. So you have a distance here from there up to there, and then from there up to there. So those distances, because this is from O to A, this is going to be A. Also, this will be A, because we are assuming this is coming to the focus. So this is going to be a distance of 2A away. So for that, one can say, for a parabola, if you recall, the distance, the ratio of SP to MP, that ratio has to give us a constant 1. So therefore, SP is equal to MP, and in that sense, we need to see what is SP. SP using coordinate geometry is going to be x minus a squared plus y minus 0 squared. Whereas MP can be got from root of x minus a squared plus y minus y squared. This will realize MP as x plus a squared. Then the other one, we have also seen what it is. And this one actually gives us x plus a as that very term. Let me call this equation 2. This is our equation 1. Now, from our equation 1, which is SP, we are seeing that SP is the root of x minus a squared plus y squared is equal to x plus a. In this sense, you can expand both sides and have x minus a squared plus y squared is equal to x plus a, close brackets, to the square. When you make y the subject, you'll have y squared is going to be equal to x plus a squared minus x minus a squared. If you're not good at difference of two squares, expand. Yeah, when you expand, you realize x squared plus 2ax plus a squared minus x squared minus 2ax plus a squared, close brackets. You can carry out division, subtraction, and lose a squared and lose x squared. When you simplify, this becomes y squared is equal to 4ax. So whoever has not been enjoying so far, you can forget whatever we have defined and have this as the equation of the parabola. So this is the standard equation of a parabola, which is a horizontal parabola. So this is a standard equation of a horizontal parabola. which is also positive, horizontal positive parabola. The other definitions, we need to note the following out of this definition. So having seen that that is the equation of the parabola, you note 1, y squared is equal to 4ax is the parabola which is symmetric about the x-axis. Symmetric about the x-axis, and it opens to the right. You've seen some of these equations in Backhouse 1, but you didn't know where they come from. Y squared is equal to a negative 4x. This is a negative parabola, or a negative, the reverse of this one we have. This is a parabola, symmetric to the, or about the x-axis, and opens to the left. Take a screenshot before I flip the page. Furthermore, yes, please. Yeah.
I'm requesting teacher to repeat for me on the first work.
To repeat for you?
Yes.
To repeat, you want to take a screenshot, or you want to?
My network. My network.
To repeat here.
Yes. Repeat for me. In the explanation.
Explanation for what? How?
Introduction for the conic.
But for the parabola here, you have got.
No, I have not been there.
Yeah, no, what we shall do, you'll visit my YouTube. I'm going to upload it today. Okay? Then you go over and over it.
Okay, sir. Okay, sir.
Because we are short of time. So the third definition, guys, the parabola can also be defined in this form. X squared is equal to 4by. This one is a parabola, symmetric about the y-axis, and it opens upwards and opens upwards. Then lastly, that is that sometimes we say it's a positive vertical parabola. Positive vertical parabola. Then x squared is equal to negative 4by. This is a parabola. This is a parabola symmetric about the y-axis, and it opens downwards. Sometimes we call it the negative vertical parabola. So we can briefly derive some two of those so that people can get to see that they actually exist by saying examples. Find the equations of the following parabola. given the focus and vertex at the origin. So A, they have given us the focus is at negative A0. Remember the other first derivation was at A0. The directrix is at X is equal to A. So the illustration on that will show the following. One, the apex of the parabola, which we call the vertex, is at the origin. The parabola looks like this. So this is how it's going to face. This is the y-axis where x is 0. This is the x-axis where y is 0. This is the directrix where x is equal to positive A. This is the origin. So we have the focus where the focus is at negative A0. Then the variable point P is here, which is xy. Okay, so if that is xy, then we can assume the perpendicular to the directrix to be that, and then we can assume the distance from the focus to the point P also to be that one. In that sense, we can have the following, that these are supposed to be equal as per the definition of the parabola. So if they're supposed to be equal, this is P, this is M. So for a parabola, the eccentricity is supposed to be equal to the ratio of P, M to SP, which eccentricity has to give us what? 1. So therefore, PM is supposed to be equal to distance SP, which will be the square root. What is PM? PM, if you look at PM here, this is X, so this is going to be A, Y. So this will be X minus A squared plus Y minus Y squared is equal to the root of X minus A squared plus Y minus 0 squared. When you square both sides, we shall have X minus A squared plus 0 is equal to X plus A squared plus Y squared. Thus, Y squared will give me X squared minus 2AX plus A squared minus X squared plus 2AX plus A squared. When you lose the 2 by subtraction, you will have Y squared is equal to a negative 4AX. That is how we can realize our negative parabola. So whenever the parabola has faced this side of the right, when it is opening to the left, it is a negative. Yeah? It is the reverse of this first one we had, whereby it was opening to the right and closing into the left. So that is its reverse. One other illustration you can have on this is the second one. The focus is 0B, and the directrix is Y is equal to negative B. Now, this one is a little bit interesting. How? It is a vertical parabola. Now, this is where its focus is. I mean, its vertex is, then this is its directrix. So according to that definition, which has been given, if this is the y-axis, and this is our x-axis, then the parabola comes and turns and opens upwards, like that. But we have a point here. The focus of the parabola is at what point? is at S, which is 0b. We have a variable point here, P, which is xy. Then from P, we go to the directrix. The directrix is this one, which has been identified as negative, because if this is 0, 0, then this is negative b. So y here is equal to negative b is our directrix. So with that sense, I can sketch the perpendicular to the directrix from P, which comes down like that. Then my variable displacement of S to P is that. And still by the same definition, for a parabola, SP should be the same as PM. Now, can you go ahead and find for me the equation for that parabola? Please derive for me. Show that SP is equal to PM. And according to this M, this is going to be at what coordinates? The coordinates are still X, negative B. So derive that equation. I want to hear the answer you get. Then you'll investigate this last one in your free time. The focus F is 0, negative B. Then the directrix is Y is equal to positive B. So you investigate those items. But first derive for me this one, so that we continue moving together when I know people can be in position to identify such equations. As people are trying to see that, I can show you more illustrations here of this curved nature. These are figures we are looking at mathematically, but mainly the best examples I can give are always on bridges. As you can see, those curves will always come in. You see that? All those curves are describing these shapes we talk about in this conic section. See those
X squared.
Okay, yes, what have you got? X squared is equal to?
4by.
X squared is equal to 4by. So you see all these beauties, they come from mathematics. Even our new bridge, I know our bridge, I think it's a cable bridge. It's not a conic bridge. These ones are conical bridges. Look at that. This is in China, I think. Look at that. See, this is a parabola now. You see that? That is a parabola. Of course, if that is a parabola, we assume it has this as its axis. It has its focus somewhere around here. Yeah. Then this is its vertex. Okay. So these are very interesting concepts of mathematics. As you mathematicians, when you bypass such items, you should be able to appreciate some of these items. Even for trains, they can be done. Their rail lines can be built using the same concept. Okay, someone has already confirmed the answer, so we can stop this image sharing and we go back to our illustrations. There's this lovely one you should also take a look at. See the mechanics there, and the mechanics and the math of pure math, which is there. There is physics, there is mathematics. So then also check this one out. See that? All bridges which have inclines, they have that curved nature coming from the conic sections. So we can always take a look at those items and appreciate. So when you see such items somewhere, anywhere, just know you are passing over a conic. See that beautiful one as well? Very beautiful. But of course, the engineers who do that, we are very good at mathematics. They never dozed at all. They solve all numbers. So you solve the numbers. Okay. So you'll prove this last one. Since I've tasked you to prove that last one, let me give you another definition. Before I can give you a definition, there is a note we need to have. Now, if the parabola is not having its vertex at the origin, what happens? Then its vertex will be shifted. So look at a parabola with a shifted vertex. The shifted vertex to a point HK. So we are assuming we have got our parabola and we have shifted it from the vertex, which was at the origin. Now the vertex has been shifted to a point which is H what? Which is HK. I'll prove only one, the rest you'll prove them in your free time. So we can note and say if the vertex has been shifted, the vertex has been shifted from the origin to a point with coordinates HK, the parabola equation is modified by replacing x with x minus h and y with y minus k. Hence, note the following. Y minus k squared will give us 4a of x minus h. Then we can also have y minus k squared is going to be equal to a negative 4a of x minus h. Then we can also have x minus h squared is equal to 4a of y minus k. Likewise, x minus h squared is equal to a negative 4a of y minus k. That is if it has shifted. So let us prove one proof that shows the shift can occur, and we arrive at those equations. So if the shift has occurred and we had this as our directrix, and we have this as our
Excuse me, teacher.
yes, please.
We are. I'm saying. I'm saying that we have you got for A.
Where have I got? 4a. And the standard equation of a parabola is in form of y squared is equal to 4ax. So we have said the x is increased by, the x is replaced with x minus h, whereas the y is replaced with y minus k. Okay?
Yes, in the first.
You've seen it, eh? So if this is our parabola.
Okay, sir, thank you. Yes, teacher.
And this parabola of ours has got focus here, which is the new focus, which is at a plus h. It's no longer at a0. Then we have our variable point here, p, which is xy. This is a new p. Then we have our directrix here at m, new prime, which is m, a new m. Then we can have our line from m up to p, and our line from s up to x. With this sense, these distances are the same. Remember, we said this distance has to be the what? The same as that one. So the directrix is at a point x is equal to a plus h. So this will be, but this is a negative, eh? This is a negative a. Because if this was the y-axis, so this is along the x, you have shifted this to be the horizontal, just the x is meaning the horizontal now. So at this point, m will be at negative a plus h and y. So still, the distance s prime, p prime, is supposed to be equal to p prime, m prime, which distance is going to be the same as what? X minus a plus h, close bracket, the whole of it squared, plus y minus k squared should give us the square root also of x minus, open brackets, negative a plus h squared, close brackets, the square is outside, plus y minus y squared. So when you square both sides, this takes us to y minus k squared plus x squared minus 2 into a plus h times x plus a plus h squared is equal to x squared minus twice of negative a plus h times x plus negative a plus h squared. So when you simplify, the x squared can vanish. Okay. When you simplify this, you can have, this becomes y minus k all of it is squared. That has made our y on the left-hand side. It's going to be equal to 2ax plus 2hx. Then we shall also have minus s squared minus 2ah minus h squared minus 2a plus 2ax minus 2hx plus s squared minus 2ah plus h squared. The h squared vanishes, the s squared vanishes. So you simplify everything. Look at the 2ax. We have a 2ax, we have a 2ah. So this 2ax and this 2ax gives us a 4ax. Shall have 4ax minus 2a minus 4ah, because this one can be added to. We have 2ax. Okay. Yeah, this one can be added to this one, while this one can be subtracted with that one. So this is equal to y minus k squared. So y minus k squared is equal to 4a into x minus h, hence proof. So no need to worry. You can have just that definition. We are just trying to prove that that is true. So no need of worrying that the proofs are becoming so many. Otherwise, we won't prove all the others. I was just confirming for you that what I have just stated there is true. So we shall just borrow in case they have shifted the coordinates of the vertex. I mean, they have shifted the coordinates of the what? Of the vertex of the parabola to be not at the origin anymore. So with that, we can have examples of questions which have figures, not proofs anymore. So take the screenshot. We have such examples which you want to see.
Why do they have primes? Like, why is it S prime and P prime?
Hey, I'm looking at them as new foci, new focus, and a new variable point, which have been realized as a result of shifting the vertex from the origin. Because we have said if you shift, the vertex of the parabola is shifted from the origin to a point with coordinates hk, then the parabola equation is modified by replacing the values of x as we have seen there. So we are looking at a point that if it wasn't at the origin, if it was at the origin, remember before it has been A0. Remember before it was the focus of A0. But now we have shifted the x with a value of h. So it becomes a plus h. Then we have shifted k with a value of y with a value of k, then k plus 0 becomes k. So that's why the focus changes to that.
Excuse me, teacher. I thought on this, the last two formulas, it is 4by, like the last two.
Okay, thank you. But it's okay, it's just a constant there. So it shouldn't worry you so much, but let us be consistent. Let us use it b. But it is just a what? A constant. Okay? So another example. Example 2. The equation of the curve. The equation of the curve is given by y squared minus 6y plus 20x plus 49 is 0. Show that the curve is a parabola. Find the coordinates of the vertex. Now, to start with, you can see our equation has been given clearly. This is y squared minus 6y can be equated to a negative 20x plus 49. Completing squares, skills are required here. Y squared minus 6y plus 3 squared minus 3 squared is equal to negative 20x plus 49. So that I create a y minus 3 brackets squared.
Negative 49.
Oh, yeah, all of it is a negative. Eh? Let's do it like that. So it's going to be giving us negative 20x minus 49 plus 9. Y minus 3 squared is equal to a negative 20 of x minus 2. Eh? Minus plus 2 plus 2. So this is in the form y is equal to a negative bx or a negative ax or a negative 4ax. One can say it's in the form negative 4ax. So they can even ask you for the a, they can ask you for everything now you can be found. So if it is in that form, it's in the form. This one is which kind of parabola? A negative horizontal parabola, if you recall. Not so. If it's a positive, it's a horizontal positive parabola. That is if you have y squared. So with that sense, it is in line with the following. One can write it as y squared is equal to a negative 4ax. Now the whole coefficient here, which is a negative 4a equated to negative 20. You see that your value of a can be got as what? The value of a can be got as 5. Eh?
5.
Then now, according to our equation, we have y minus 3 squared is equal to a negative 20 of x plus 2. In that sense, remember this was in form of y minus k squared is equal to a negative 4a of x plus x minus h. Now, do you see that our h by comparison, h is negative 2. By comparison, our k is positive 3. So the coordinates of the vertex are what? Coordinates of the vertex are negative 2 and 3.
Excuse me, sir.
Yes, please.
Sir, I please beg your pardon from the beginning of the question. I was not hearing.
Yeah. You know, the equation was given like this. Eh? So I decided to separate the variables and keep x together and y together. So when I kept the y's together, I had to design the y in this form, which required me to factorize it using a difference of 2 squared. I mean, no, completing squares. So when I computed squares, you have to have the 6, which is on linear x, square it and subtract by itself. So it gave us this. So this subtraction has to cross over. So the only part here which we have factorized this one, I can rewrite it as that x, as that, meaning it came from such an expansion. That gives us the left-hand side. Then the other right-hand side, you take up there the 9 and simplify, then you factorize. When you factorize, you do the comparison, compare that equation with the general equation we saw. Okay. Hence, you can estimate the value of h and the value of k.
Excuse me, sir.
Yes, please.
When at what condition do you use for by and for ax? At what condition?
I have said a and b are just constants. Ukasha. I can even write it like this. I am correct. I can even write it like this. That is also a correct parabola. Eh? Do you know that?
Excuse me, teacher.
So, but whether you use A, whether you use B, whether you use C, a constant, as long as you are defining y squared is equal to a constant times linear x. it is a parabola. Are we together? Or x squared is equal to a constant times linear y. It is a parabola. Kasha, is that okay?
Okay, sir. Thank you.
Yes, Habiba.
Teacher, when we are getting the coordinates, don't we add the h plus k? Sorry, the h plus a.
No. We are assuming, remember, if you go back to the definition, we had assumed the vertex had shifted to this coordinate, to this point, HK. It is the focus which is that. If they ask you for the focus, this is the vertex. This is the vertex. H what? HK. Okay? Is the what? Is the vertex. When you shift away from here to the focus, that is the constant A. So that's why here we have A plus H. But because we are on the same horizontal line, this is K maintained because it has not changed via Y yet. Abiba, does that make sense?
Yes, teacher.
So if they ask for the focus, okay, let us get the focus. S will be A plus H, which is going to be 3, and K, which is what? Because the focus is A plus H and K. Are we together? Some questions will come when they ask you for the vertex, focus, whatever. They will ask you many items. So find the vertex, axis of symmetry, focus, you hear now this one, and directrix of the following parabola. And hence sketch the parabola. And hence sketch the parabola. Very interesting example. First and foremost, my friend who was asking me how she missed the first part, the parabola is y squared minus 4y minus x plus 3 is 0. Y squared minus 4y is equal to x minus 3. Completing squares, y squared minus 4y plus 2 squared minus 2 squared is equal to x minus 3. So y minus 2 squared is going to be equal to x minus 3 plus 4. So y minus 2 squared is equal to x plus 1. Habiba, do you see that the constant here is 1? Our
Yes.
4a something. Eh? So to
So
start
where do you
with,
get the equation
can you identify for me, Habiba, what is the value of k and the value of h?
The value of k is, it is -2.
The value
It's
of k
2.
is -2. It is positive 2.
No.
Then the value of h,
-1.
h is equal to -1.
So where do you get that equation from? Y squared minus 4y.
Hmm?
Where did you get the equation you're working on?
The question, I never wrote it down. Okay, the question was y squared minus 4y minus x plus 3 is 0. Then we are seeing that the vertex now is what? The vertex is, it is KH. Eh? Oh, it's HK or KH? I think it's HK. So it's -1, 2. Solution. Axis of symmetry. The axis of symmetry is which one? Do you see this axis of symmetry here? This x-axis we had, this x-axis was y is equal to k. So this is what we call the axis of symmetry. The axis of symmetry is what divides the parabola into two. Your parabola is, depending on this is the axis of symmetry. It divides this half and that half. Okay? So according to this new shifted point, it is at a line y is equal to k. So in this question, they're asking you the axis of symmetry. The axis of symmetry will be what? Y is equal to?
1.
Yeah? Y is equal to? The axis of symmetry is the value of k. So y is equal to 2. Okay. We get that? Now, the last bit, remember this is the 4a. This is 1. I can get my a, which is 4a is equal to 1, and my a is equal to a quarter. They have gone further and asked us for the focus. Remember the focus S is a plus h and what? And k. So the focus will be a quarter plus -1 and 2. The answer will give me -3, 4 over 4 and 2 as my focus. 5, they have asked for the directrix. 4, the directrix is got from where? Go back to our definition here. The directrix is x is equal to -a plus h, right? So if it's -a plus h, then we can substitute here and say the directrix is x is equal to -a plus h, which will give me h. A is what? -1/4. H is -1. The answer is -5 over 4. It's our directrix. That is why I was deriving for you all those definitions. If I had just jumped and say, hey, let us go ahead, find it, come on, I would be confusing you so much. So in case there is anything you miss out, refer to the notes. Okay? Now, they have said we sketch. Before I sketch, let me first mention, you want to screenshot? First, when x is 0, you will see that y minus 2 squared will be equal to 1. So y will be equal to 2 plus or minus 1. So y1 will be 3. Y2 will be 1. Okay? So the parabola crosses the y-axis at what? At 0, 1 and 0, 3. So that is why they want to test you and sketch, and they see whether you've understood how these lines of the parabola are actually looking like. So if this is our vertical axis, if this is where our directrix is, according to that, if this is our y-axis, and this is our x-axis, then we have seen that the parabola is cutting the y-axis at y is 3 and y is 1. Actually, this is not the x-axis. This is just the axis of symmetry. And y is 1. So if this is where the origin is, the origin now can be down. The origin is down. This becomes my x-axis. So where is the focus? The focus is at what point? We identified the focus at
-3.
-3, 2. The focus is at -3, 2. Now, if this
-3 out of 4.
now this is the line where the 2 is on the y-axis. This is where the 0 is. So -3 out of 4 can be somewhere around here. The directrix we said is at -5 out of 4. And this could be 1, negative. So at this point, we expect the parabola to turn and go in that direction. Then here to turn and move in that direction. Hence, that is our sketch for y minus 2 squared is equal to x plus 1. Okay. The second quiz question on that number 2 was x minus 3 squared is equal to 3 of y plus 1. So you need to compare this with our definitions of x minus h squared is equal to 4p of y minus k. Remember, they said replace y with y minus k. Replace x with x minus h. Now you'll see that h is actually 3. K is actually -1. P is equal to 4 out of is equal to 3 out of 4. Okay, so to get the focus, remember the focus is you get what? The axis of symmetry, first of all, the axis of symmetry in this case, this is a vertical parabola. Yeah, so the axis of symmetry, because it is vertical, it should be a vertical line from the x-axis, which is at x is 3, because it is occurring at hk. So the vertex is at 3, -1. So this value, because the parabola is in this order, its axis where it is at a vertex of where x is 3 and y is -1. So if you look at this entire line, it is the line of x is 3. So the axis of symmetry is x is 3. So this is trying to shift, or trying to be different from the other one. Now in this case, because the h is not changing, to look for the focus is, this time round it will be having the h as a constant, whereas it will have that k, which is a -1, added onto the what? The p. The other time we have been seeing a negative a plus h and k for the other horizontal parabola. That is why you need to have all these definitions at hand. So the focus becomes, what is our h? Our h is 3. Then we shall have -1 plus p, which is 3 over 4. When you simplify, the focus becomes 3 and -1/4. Then the directrix for this one, the directrix is going to be got from what? From k minus p. Where is our minus? So k minus p, which will give us our k as -1 minus 3 over 4. And this will give us a -7 over 4. So you have to be able to identify the directrix, axis of symmetry, the focus, in a way of relating with the definitions that I have already mentioned. So with that, they can also ask us to sketch the curve. So in sketching the curve, this is what we are going to expect. So to sketch, let us first identify what happens? The curve is x minus 3 squared is equal to what? 3 into y plus 1. So when y is 0, you realize x minus 3, because when you get y is 0, it gives you the two cutting points. So this will give us x minus 3 is equal to plus or minus root of 3. So x1 is root 3 plus 3. x2 is root 3 minus 3. Sorry, is negative root 3 plus 3. When you compute this with a calc, you get around 4.73. This one will give you around 1.27. So let us now sketch the curve. So in sketching the curve, this is what we are going to expect. First and foremost, you will have, see as your y-axis, can have this as our x-axis. Then where is our directrix? Our directrix is at x is equal to 3. So if our directrix is at x is equal to 3, then this is my x is equal to 3. I mean, this is my axis. This is symmetrical axis. Then the directrix is at y is equal to negative. Y is equal to negative 7 over 4. If that is the directrix, sketch the directrix and have the following. Our directrix is right here. Where is our vertex? Our vertex, according to the question, our answers, the vertex we have seen is at 3, negative 1. 3, negative 1. Where is, if this is 0, 0, this is x-axis. 3, negative 1. Negative 1 is here. So this is where our focus, our vertex is. Then we have the points where the curve is cutting the axis. One point has been 3 minus root 3. The other point has been 3 plus root 3. So we are ready to sketch the curve. Like that. So this is our curve. X minus 3 squared is equal to 3 into y plus 1. Okay. So with that, you have sketched our parabola. So time is against us. Let me leave you with these few assignments. Sketch the curve. Sketch the curve. Y squared is equal to 12 of x minus 4. Now we should be able to look at it. Remember the other curves we did in curve sketching. They are slightly different from these ones. Yeah? So you can be clearly looking at this one and say this is a parabola. So if it's a parabola, you should know how to get its focus, directrix, axis, intercepts, and so on. So you sketch the curve. So you'll do that one. Find the equation of the parabola. They can also give you another one. This is equation 1, equation 2. Find the equation of the parabola. Find the equation of the parabola with vertex 0, 3 and P is equal to 3 if it is a concave upwards. Okay. Another one. Find. Here the answer is, if you need the answer, but you try it. Okay, the answer is x squared is equal to 12 into y minus 3. This is the answer. Another one, find the equation of the parabola with the vertex at a point 1, 1. And the focus is 1, 8. The rest I'm going to sketch them and send them for you, which will also include properties of a parabola, so you can read about them. The next lesson we shall introduce its further properties, tangents, lactus rectum, equations in terms of trig, and so on, in terms of t, and so on and so forth. About its code, yeah, we shall see whether we can try to summarize it next time. Okay, with that, you can have a good day, unless if someone has a question.
Teacher, help go back to the previous page, please. Excuse me, teacher.
Yes, I'm going back. Previous page. There you go, that one.
Thank you, teacher.
You're welcome. So about the axis, you should know, how is the parabola? Is it vertical or horizontal? Then you should know that axis, if it's horizontal parabola, the axis is a horizontal line. If it's a vertical parabola, the axis is a vertical line. Okay.